So today we are going to talk about resonance. First, what is resonance? Resonance is basically a phenomenon which occurs in RLC series circuit as well as RLC parallel circuit. So, what a circuit in resonance does? If a circuit is in resonance, its current and voltage will be in same phase. So resonance define stability. Okay, so here as you can see that the voltage and the current are in same phase. Okay, so this is resonance, nothing else. Now let's talk about when resonance happens or when resonance occurs in RLC circuit. Whenever the reactance of the inductor and the reactance of the capacitor are become equal, then the resonance occurs. Why? As we know that the impedance Z equals to square root of R square plus XL minus XC whole square. So this becomes R in resonance. Why? Because XL equals to XC. So now as we know that what is XC? XC equals to 1 upon omega C, and what is XL? Equals to omega L. So as the inductance of the inductor increase, XL will increase, and whenever the capacitance of the capacitor decrease, the XC will increase. So now, or we can say that when this C increases, XC will be decreased. Now after some time they both will equal, that is XC will be equals to XL. Now it will be like this, that omega square will be equals to LC. So from here we cannot conclude anything, but we know that omega equals to 2 pi f. Now as we studying resonance, so the frequency will be also resonating frequency or resonance frequency. Now we can clearly do like this, that 4 pi square FR square is equals to XC. That implies FR equals to 1 upon 2 pi square root of LC. I am doing a small step jump here, hope you will understand that. So the final result is this. This is called the resonating frequency, as I told before, and this is the resonating or resonance condition. Okay, when the frequency will become 1 upon 2 pi square root of LC, then the resonance will occur in RLC circuit. Now let's see the effect of series resonance. Okay, that means the effects. So the first thing is the current will be maximum. The current will be maximum. Okay, and what next? As we see just that Z equals to R, that the impedance is equals to the resistance. and for what? For XL equals to XC. Okay. Now the third thing is sorry. So now the third thing is the Q factor or the quality factor of resonant current. Okay, so Q factor. We will talk later about Q factor. So now just know this, that Q factor is equals to voltage drop across anything, any like L or C, okay, upon the supply voltage across L. Let's say the supply voltage. Okay, so this is the Q factor for inductor. So what will be this? IXL. And what is this supply voltage? It will be IR, because there is just R. Before this we can write like this IZ, but now it will be IR. Okay, so the supply voltage, one second. So now the Q factor will be XL upon R for inductor, and the Q factor for the capacitor will be IXC upon IR is equals to XC upon R. Okay, so now we can write more from here, that what is XL? XL is omega L upon R, and this omega will be obviously for resonance, and here we can also write like this omega R C R, like this. Okay, so from here we can write like this 2 pi f R into L by capital R. Okay, so what is FR? From here we can see that 1 upon 2 pi square root of LC. Okay, so right here, and after writing this we will get square root of L here, and upon RC. Sorry, the R will be outside of the square root. So we will get 1 upon R square root of L upon C, and from here we will get like this, let's say 2 pi f R C R, and from here we will see like this square root of LC upon 2 pi CR. So similarly, so we can see that the quality factor or the Q factor is same for both the cases. That's it for today. Thank you.